Okay, we are at the second lesson, 112, expressions continued. We learned a little bit about expressions yesterday, so I just want to point out, let's see, I'll hold off. I was going to point out different parts of the function. Oh, we have one here. Okay, what is the coefficient in this function right here? Coefficient? Yes, Jude. 2. It goes in front of the x. It's 2 times x. What's our constant? Constant is 1. It's by itself. 1 is always 1, right? 1. Okay. You can make a theory against that if you want. But hold that on. Okay. One thing to remember. We can only combine like terms. And how do we know if it's a like term? What do we look at? What distinguishes if it's a like term? Yes. The exponent, okay? Based on the exponent. That's key. That's key. Put a little key right there. Based on exponent. Right? Okay. Next, we have to remember Pemdas. Pemdas. So let's just remember P is? Next, P, exponents. M, D, A, S. Okay, very good. Now, if you had a bunch of terms in a row and they're all multiplied together, you would just do them from left to right, just like you read. Western academia is reading left to right, and math follows that same kind of Western tradition. Okay, so if you're ever confused, just default back to, well, it's the same as how you read ascending order as well for our variables, left to right. Okay, so let's look at this. So the first little part, does 5 times 3 to the x equal 15 to the x? First of all, I want you to think about what did they do in order to conclude that, and is it correct? I'll let you talk to your neighbor for, let's go 15 seconds. Maybe 20. Talk to the neighbor. Talk to somebody, not to yourself. All right, let's see. Loretta, what'd you come up with back there? Or even if you don't know if it's right or wrong, what did they do? How did they figure that out? How did they conclude that 5 times 3 to the x power is equal to the 15 to the x? What did they conclude? How did they conclude that? Sorry. They just multiplied. They multiplied 5 times 3, which is 15. They said, well, that's still going to be raised to the x power. Now, thanks for starting us out. Can anybody conclude or tell us, is that conclusion correct? Jackie, what do you think? Why is it not correct? These are not like terms, and there's actually another aspect to it. It's correct that they aren't like terms, and we have to deal with Pemdas. So how about you explain a little bit, why is it also incorrect with Pemdas? Because like terms or not, if we're multiplying, we can actually multiply a 3 and an x to the 5th. Okay. So it's less about the like terms, it's more about the Pemdas. Do you want to pass it on, or do you have an idea on Pemdas, why that's wrong? Pass it on. Okay. Jude?
Because exponents are first.
Exponents are first. Let's look at the order. If it was parentheses right here, right? Then we would multiply them. But we have to look to see, are there exponents? Yes, the exponent is applied to 3. So think of it this way. If we had an actual value for that, already? All right, if we had a value for that x, right, it was 3 squared, right? Then that would be 5 times 9. That would be 45. Now, if we did it like they did it, and it was 5 times 3 squared, and you said, well, that's just 15 squared. No, that's 225. That's definitely not correct. Okay. Pemdas tells us what to do first. In your explanation, you could say information about like terms or Pemdas. But let's see about how we feel about that. Thumbs up, sideways, down for just like what we just did right there, that little exploration. Feeling pretty good. Okay. Let's look at the second one. I'll give you 30 seconds. First look at it and tell your neighbor, is that correct? And tell me why. All right. I'll just take a volunteer. Who feels pretty good about this? Yes. Alondra.
No, because the 10 and the 2x are not like
Good. Good. Could we multiply those two together? Could we multiply 10 and 2x? We'd get 20x, wouldn't we? See that? But you're right. With addition, when we're adding or subtracting, we have to have like terms. The rules are a little more open with multiply, divide. But this is incorrect because 10 plus 2x is 10 plus 2x. We can't combine those. If we did, we certainly, what they're saying is basically you got 12x and then you divide it by 2 and you got 6x. But they made that mistake. And the reason for that is can't combine the like terms. That's perfect. Okay. Good. Pretty good with this first part. Okay. There's, let's see, there's like maybe 6 problems you have to do that are like this. When you explain, I'd say stick with those main points. All right. Next, function machine. A function machine, I like to make this little drawing because you have an input. And in general, we're putting in x. We're putting in different values for x. You guys have done the table, where you kind of do a table, you get some x values, you do the work, get your y values. Okay. So you've seen this. We have an x value that is going to be inputted into the function machine, which I'll abbreviate function like this sometimes, funx. Okay. The function machine is going to process an inputted x value and end up with a y value as our output. It goes in, it's plugged in, evaluated, and it goes out. Okay, so let's go ahead and do the first one together. We have 0 for x. We're going to go ahead and plug in 0 for x. And that one's really pretty straightforward. So what do we get with that? 1. Big 1. Because 0 times 2 is 0. Plus 1. All right, I want you to do the second 2 here on your own. We're going to plug in 1, evaluate. Evaluate is just another word for plug in. So we're going to then plug in or evaluate. 2. So do those real quick, then just check over in your neighbor, see if they also got it perfect. Okay, feeling confident? Isabel, help us out. What'd you get here when you plug in 1? 3. 2 times 1 is 2 plus 1 is 3. How about when we plug in 2? 5. Perfect. Perfect. You guys seeing how we're going to process these? And this is a little bit of review. It's perfect because we are going to build off this. But the main thing we're doing right now is just having an input value and an output value. Now, in the problems, they're going to say, well, they're going to ask you a question. Okay, they're going to ask you a question like this. What happens when you change your input value? What happens to your output when you change the input value? Right? So, if we hadn't even done this work, would you be able to figure it out? If I increase my x value, what's going to happen to the y value? Is it going to go up or down? It's going to go up. So you can logically conclude it, right? But this is how you prove it. So when you get to these problems, it's going to be presented almost like a word problem, like over here. I need you to prove it by doing at least 3 values to prove that it is going up. Okay? It's just a little bit of practice. We'll be able to see if it increases or decreases just logically, but it's not always going to be like that. So we want to have that plug-in evaluating process really quick. We got one more example. All right, a new car costs $25,000. Who knows what car costs $25,000 to start? Anybody? Just told one last period. Some kind of Subaru. You guys aren't ready to buy a car yet, so you don't care. Is that it? Don't care. Yeah. Like a Dodge, like what's the one that they have? Dodge. What's the model? This is really important. Wait, did you say something? Charger. Oh man, that would be like the Charger probably that like has the basic wheels, no seats, doesn't have seat belts, no air conditioning, but $25,000 you might get out the door with it. Now, once you drive it off the lot, is it gonna earn money or lose money? Lose money. Maybe if you had bought like a perfect, Chevy Nova from the 70s or an old Dodge Charger that's perfect, or a GTO, or like these old cars, eventually, they would depreciate, but as an antique car, they would go up in value as well. That's a different story. For basic cars, if you buy it, once you buy it, it starts to depreciate. Less money, less money. So if you were to come into a lot of money, or you get a job, your first job, you make a lot of money, you did, don't go out and just buy the nicest car you can find. Because that investment is nothing but just giving your money away. I mean, have a car that you enjoy, that's good, that meets your needs. But investing in a really expensive car isn't the best idea, because that money isn't going to ever compound and get you more. You buy a house, your house, the value goes up, and you have more money from that. Okay. So just think about this. Investing in a car is probably the least intelligent. I'm sorry if your parents have really nice cars. I'm not saying that to you. Okay. That was a total side note. So we're going to go back now. All right, new car costs $25,000. It depreciates in value. How much? $1,800 per year. After the first year, it's worth $1,800 less. Okay, here is the equation. 25,000 minus 1,800t represents the value at t years since you bought it. Makes sense. Find the decrease in value for the first 3 years. Okay, so I'm going to do the first one, and I want you to help with the next ones. We're going to say the value is equal to 25,000 minus 1,800 times 0. 0 for t, that's how much? How much am I going to end up with? 0, right? That's 0. 25,000. Now think about that. Does that make sense that, before you buy it at times 0, it's still the value is 25,000? Yeah. You haven't signed the contract. You haven't paid anything. It's still on the lot. You're still getting the hustle of the used car salesman trying to get you to buy more stuff. So you haven't bought it yet. It's still worth that amount. All right. Now I want you to go ahead and we'll do the next two. Let's do them independently. So go ahead and work this out. You might need a calculator, but let's work it out for after 1 year, how much has it depreciated, and then for 2 years. And I think from that, we'll just be able to do number 3 together. And then check with your neighbor, or if you don't know. If you're in your group and you're feeling sharp, you know this stuff, it's also good. You'll start to do it naturally, but I want you to look out for others in your group. If somebody just looks like they don't know, ask them if, what they think, get it going. It's a really good skill. It's uncomfortable at times, but you gotta learn that skill of being proactive. Take you a minute. Okay, check with your neighbor. Last seconds here. Keep working if you're working. We're going to bring it back in just a moment here. All right, let's see what we got. Okay, who's feeling confident? Who's feeling confident or with the help of their group? Really confident. Okay, who's feeling mildly confident? Mildly. Mild hot sauce. Yeah, that gotcha. All right. 1 year.
So on the one, you should subtract the 1,800 by 25,000 one time.
Okay. You subtract them from the total.
Yeah.
Okay. And you get
23,200.
perfect. We agree? Everyone agree? Yeah, I see head shaking. Good. Anyone else mildly confident? It's like the hot sauce where they have the little pepper on the bottom, but it's not even on the pepper. It's on the very bottom. All right, what do you think?
So, 25,000 minus 3,600. 21,400.
I say 400?
Yeah.
All right, what do we think? 21,400?
Yeah.
Is good? Okay, this one's not even done out here, but we're going to go with Leah.
So the answer is
19,600. And that would just be essentially... Did you just correct me? How dare you correct the teacher, class, embarrass me. You get a candy for that. That's what's going through a lot of teachers' heads. I'm embarrassed. Everyone hates being embarrassed, right? I try to embrace it. It's my personal growth for the year. Okay. 1,800 times 3 is... How much is that? 5,400? So when we subtract that, that makes sense. I always check myself just to see if that 4 and the 6 made sense. It does. Okay. All right, how do we feel? Thumbs up, sideways, down. Thumbs up. We're good. That's good. All right, so now. All right. Right now I have 188 subscribers. I'm looking for like 500 by the end of the year. 500. I'm a nice conservative goal. And so how are we going to entice? What is the prize giveaway for my 200th subscriber? 200th subscriber gets what? Give me some ideas. Donuts. All right. That was quick. Sorry, guys, we ran out of time. How about a king-size Kit Kat? For the 200th subscriber, please subscribe. How about subscribe on 3? 1, 2, 3? Subscribe!